networking, network types, and topologies. And now we come to what makes, in my view, computers and technology today so interesting, which is the concept of networking, or being able to connect multiple computers and multiple devices together so that they can share in processing power, information, and so forth. But before we get into really the complex stuff, we need to talk about we need to take a step back and talk about some of the terms, terminology, and what are called topologies, or how networks are put together, which is represented by this right here. So we're going to spend this first video going over the network types, the different types of networks, and the topologies, or the ways that networks are constructed. Now, some of this might be different than what you have encountered in the field. Some of this might have different words you might have heard. That's okay. What I'm trying to tell you are some of the official terms and how they're used on the exam. So you might talk to people who have different names for things, but this is definitely one way to name everything, and this is also how the exam talks about things. So what we're going to start with is looking at a very brief networking overview. And again, what's interesting to note here, I just like to always note when we talk about this, is A+ contains networking and security. Okay. However, there's also a Network Plus and a Security Plus exam. So this is a brief smidgeling of what we're going to be able to cover in Network Plus and Security Plus if you're going to continue to take some of those as well. So I just want to cover that really briefly. So when we're talking about an overview, this overview is extremely general, a 50,000-foot view, as opposed to Network Plus, which gets a little closer, but still not as even in-depth as some really intense stuff. Okay, so we're doing a network overview. Then we're going to deal with network types. These are the types of networks that exist, and they include a LAN, or a local area network, a WAN, or a wide area network. There are several LANs in a WAN. These are the two major ones. Then we have what's called a metropolitan or municipal area network, which is a type of WAN. And then a personal area network, which usually on the exam has to do with the network created by Bluetooth devices. Okay, so we're going to talk about all these. You can see that these all end in AN, area network. The idea is what is the first word, and that's going to give you a clue as to what the rest of the stuff is. There are some that we're not going to cover, such as a CAN, or a campus area network, but I think you will get the idea as we go forward that these are subjective names that are really applied to groupings of computers, not so much for technical means, okay? Then, after we talk about the different types of networks, we're going to talk about the topologies of networks. Topologies are how the network is physically laid out, or logically. In this case, we're talking physically. And the ones we're going to look at are star, bus, ring, and mesh. We also are going to briefly mention hybrid. So we will talk more in depth about topologies. We'll talk even more in depth about them when we get into Network Plus, because here we're just covering the ones that we need to know for the exam. All right. So first, the networking overview. A computer network, and again, this word network is something we see in other applications, not just computers. But a computer network consists of two or more computers that communicate to share files, access databases, collaborate on projects, connect to the internet, etc., etc. Now, I would even open this very formal definition up and change this word computers to nodes. Because now, this says a computer network, but I would say a network, information technology network. And by the way, the internet is an internet work. It is just the largest network that exists. The internet contains not only computers, I mean, I guess that's the definition of what is a computer, but a smartphone is a computer. A printer to the extent that it has a processor and a board and RAM, is also a computer. So when we're talking about computers, we're also dealing with these nodes, all right? And there are different types of nodes that we discuss. So if I use the word nodes, that is sort of in reference to a computer or any device that plugs up to a network. It is some important considerations to include in networking, and these are what we're going to talk about over the course of this entire lesson. All of these videos on networking are the technologies used, devices, protocols, cabling, hardware, in other words. What is the hardware that plugs everything up together? The installation, configuration, and troubleshooting, which is not just physical, but also the software we use. How it is organized, which is the topology, which we're going to discuss in this video. The types of communications necessary, meaning ports and TCP/IP, how they communicate over this hardware technology. How the network is secured. And this doesn't just get into security plus, but don't forget, anytime you have something of value, you want to protect it. That's why your home is secured. So we want to make sure our networks are secure, not just our computers, but our networks in general. And the effect of the network on a budget, because there is a cost involved. All this stuff costs something, and so we need to start saying, what are we going to pay for and what isn't worth it to us? A home user is going to have different needs than a business user. All right. So let's now talk about network types. Computer networks could inhabit a room, a city, or computers across the globe, which we'll call the internet. And each one is going to have a different name given to it. These are all generally categorized, meaning that if it's inhabiting the entire city, we could call it a couple different things. So what I'm going to try to do is give you a brief overview of how we categorize these different networks into types, because you are going to see these quite a bit popping up on the exam and just in life in general as an IT person. The first one, and these are the ones we're going to look at, and we're going to look at them more in depth. The local area network, which might go towards this one, inhabiting a room. Look at that word local. A wide area network, which as the name implies, excuse me for that, as the name implies is wide, large, also known as a LAN and a WAN. That's how you're going to see them more frequently called. Generally speaking, a WAN is comprised of many LANs. The metropolitan or municipal area network, which is more about encompassing an entire city. Obviously, I could have many local area networks in a MAN, and quite frankly, a WAN and a MAN could be sometimes called the same thing, right? But we're going to talk about that as well. And then a personal area network, much smaller perhaps even than a local area network. And again, I usually see a PAN or a personal area network when we're dealing with Bluetooth. So let's first talk about a LAN versus WAN. These are two really important distinctions we need to make. A LAN is a group of computers and other devices that are located, generally speaking, in a small area. So this could be an office, depending on how we designate it, a home, a room perhaps, even the floor of an office. So it's any of these are how we designate it. What really makes a LAN different, and we'll talk about this when we get into some of the hardware, is that they all connect to each other through switches. Okay? So everything within a LAN connects through switches. And we'll talk about that when we get topology and when we get into hardware as well. But there's an important distinction to make that we're not getting to a router, which is a term you may have heard of and we'll talk about more. We don't start dealing with routers until we need to get out on the WAN. It's like this. A local area network would be, for instance, your building. If you live in a building or your neighborhood, you know where everyone is. If someone came up to you and said, hey, can you show me where Bill's house is? You could say, oh yeah, Bill, he lives down the corner. But if I asked you, hey, where does Bill live? and there's no Bill in your neighborhood, or I want a Bill who lives in a completely on the other side of the city or on the other side of the world, you're going to need to reference your phone book, or you're going to need to get on the internet and do a couple searches. In the same way, switches can only communicate with devices to which they know that are locally connected. And so one of the things with a LAN is that it's in a small area that we can administer from a small central area. We're not going out anywhere beyond that. And as a result, the switch knows the location of every computer or node that's nearby. A router, I almost said router. A router is what is going to allow the LAN to communicate with the rest of the world. Okay? So just like your post office allows you to send messages, or I mean literally snail mail messages, letters, to people in other parts of the world, whereas if you wanted to give someone a letter, you could send a messenger. In New York City, where I live, you can send someone by bicycle to deliver a letter to anyone else in the city, really. But if I need to send it to someplace overseas, let's say in England or Australia, then I'm going to have to use a router. I'm going to have to use the mail server. I'm going to have to use U.S. Postal Service or FedEx or UPS or something. So that's the difference. The router is going to allow the LAN to communicate out to the rest of the world, out to the wide area network. The LAN is the local area network. Now, a wide area network is a group of one or more LANs. So if you imagine over a large geographic area. So if you imagine that each one of these is one of these, that's what a WAN would look like. So if imagine that this is a LAN, and this is a LAN, and this is a LAN, right? Basically, the internet is just comprised of a lot of smaller LANs. Now, those LAN, how we define those could be as a WAN or a LAN, it depends. But generally, when we talk about WAN, wide area network, or you see that term on, say, a device, they're referring to the internet, which is the biggest WAN in the world. Of course, we could be dealing with WANs, for instance, multiple offices. So if I had some telecommunications company to help me, I could connect. Let's say I owned all of these. This was my Houston office, and this was my New York office, and this was my Tel Aviv office, and this was my London office, and this was my Shanghai office, let's say. Okay, so if I owned all these and I got the help of a telecommunications company, I could then connect all of these together. And we'll talk about that a little bit more. Likewise, when you go out to the internet, you need a telecommunications company or an internet service provider to help you reach out past your local area network to the wide area network. Each LAN also requires a router to connect to each other. So there's always going to be a router connecting each one of these to the WAN. The WAN itself has no limit. There is no size limit. So the WAN is comprised of many LANs. Now let's talk quickly about MANs and PANs. A metropolitan area network or a municipal area network is used when a company or, say, a government or an organization has two offices or more in the same city. So the idea is it's sort of like a WAN, but the WAN is constricted by a municipal area. A telecommunications company helps create a high-speed link between the two offices, or you use the internet to connect them using something called tunneling or virtual private networking, which we will discuss a little bit later on. This is similar to a WAN because it still needs a router, but it's just in a smaller geographical area. This term has come into use more frequently over the past few years. Again, it is subjective in use. So someone might call it a WAN, someone else might call it a MAN. theoretically, I would say a metropolitan area network is a WAN, a wide area network, because it is not constricted by, say, a room or a building. That being said, I'll leave that up to people who are designing it. When they're calling it something, they need to call it something different. Now, this is different, but very different, actually, from a personal area network or a PAN. This is a smaller computer network used for communicating between smartphones, PDAs, other devices. In other words, it's to have your computer communicate with your mouse, communicate with your smartphone. Okay, again, every time I see PAN on the test, it is in relation to Bluetooth. So this is generally attributed to that Bluetooth communication. If you see it on the test, and I write it twice, I wrote it and typed it, remember Bluetooth. Boom, PAN is Bluetooth, okay? And these are also ad hoc, meaning unlike some of these other devices, these other network types, ad hoc means that there is no centralized controlling device that you connect through. So whereas a lot of the devices have switches like we saw, and I'm about to draw a star network, right? Everyone connected through a central, all my computers are connected through a central switch. These devices, there is no central switch. They just connect with one another. So we just gave a brief overview of networking, the networking being nodes or computers that are connected together for some sort of purpose. Then we looked at network types. Local area network would be your home or a floor of a building or the entire building, depending on how they wanted to do it. Okay, a wide area network, generally outside of a geographical area. The best known wide area network is the internet. A metropolitan municipal area network, I'm going to say, is like a WAN, but it is city restrictive, or a metropolitan area. So if you have 5 offices in London, perhaps you're going to connect all those offices together. And then a personal area network, which again is Bluetooth. So now that we've talked about these network types, let's discuss network topologies. So there are 5 network topologies we're going to discuss, the 4 pictured here, and then a 5th called hybrid, which is a mix of these. The network topology defines how the devices are physically cabled together or how they logically communicate. Okay? So these could be literally physical designations, how the cabling, right, actually runs, or it could be logical, meaning this is how data is transferred. And sometimes what we'll have something that physically connects in one way, but logically connects in another. So it's important to make the distinction between a physical topology and a logical topology. What we're discussing for A+ is a physical topology. We're not discussing logical topologies. We will get into that with Network+. So we're literally talking about how these devices, these computers, are physically connected to one another. Okay? So let's look at the first one, is called a bus topology. This is very rare in today's networks. In fact, most of these are very rare in today's networks, except for star. All computers are connected to one backbone cable. It's called the backbone because it does the brunt of the work. Okay? So every computer plugs in to this network cable. Sometimes they used to do this via something called a vampire tap, which I don't have a picture of to show you, and it's not on the exam anymore, thank goodness. But this used to be something, if I had a very thick cable, imagine this being a very thick cable. A vampire tap was literally connected and had metal teeth that fed directly into the metal of the cable, and that's how you accessed it. So this would then connect up to one wire. Or there were sometimes what were called T-connectors, right? Which, as you could see from the looks of this, I'm just going to erase this for a second. Makes upside down T. Here are the T connectors. So you would have coaxial cable, for instance, with a T connector. And you would also, just like with SCSI, if you remember SCSI, we would terminate the ends of this network so it knew where to end and where not to end. But we're getting a little into logical. The problem with this setup, though, is if this cable gets destroyed, right, all of these computers now cannot communicate. In some cases, if one of the computers goes down, that can also disrupt communication. There's another one that's similar called a line network that literally looks like this. Some people refer to this as a bus. If one computer gets destroyed, none of them can talk to each other, which is why this bus at least makes a little more sense than this line. If you want to add or remove computers from a bus network, you have to take the network down. Obviously, the entire thing has to go down for me to add another computer. If this didn't exist, I'd have to take all these down so that I could pop it in there. Okay? That's the downside of bus and why it's not really used anymore. It doesn't have to be used anymore either because we have what are called switches now. So let's get into a ring, which is kind of different. So remember we talked about a line? A ring means, and this is also very uncommon nowadays, but basically there's no central connecting device. Every device connects to the next device until they create a ring. This is kind of like that line, but in a circle. So literally this guy, if this guy wants to talk, let me draw this out like this. If A wants to talk to, let's say D, okay, then he has to go, and this can only go in one direction generally. So he has to go through each computer before reaching D. And then D has to go to these two computers before getting back to A to communicate. And they have to keep doing that. And so you can see how this is really not practical for modern day computing. You also have to bring down the whole thing before you can add a computer. And if one cord goes down, one connection, the entire thing is shot. Obviously, if one computer goes down, the whole thing is shot. So this is really not useful in today's market. Some very advanced networks where we're dealing with like very expensive servers and very high-end reliability stuff will use ring networks. They generally use them not in the physical sense, but in the logical sense, meaning that data is passed from one to the next, and they actually physically connect through a central device. So the device says, you first, now you, now you, now you. It goes like this. And so they communicate in a ring, but very unlikely. The only reason some people have them is because they're very old, and sometimes if it ain't broke, don't fix it. And there can be some benefits to a ring topology that go beyond the scope of this course. So let's talk about the star topology, which I think is by far the most common you're going to see today. And it did away with 90% of the bus and ring topologies worldwide when this was introduced. And the reason is you have a central connecting device, like a switch, that unites all of the computers on the local area network. So if the connecting device goes out, you're in trouble, right? However, if this computer goes down or this connection goes down, you still have connections between all the other computers. So this was a lot more reliable, not to mention easier, because if I want to add a computer, I don't have to take the entire network down. I just plug into the central device, which is why it's really the most common and most useful physical topology that's out there. We also have a mesh topology. Some people call this a full topology. Every device connects to every other device. So you can see in this case, this guy has a connection to every other computer. This way, he has a direct line of contact to every other system on the network. Very rare, And the reason is because this could be a lot of connections. Obviously, it's the total number of computers minus 1 because you don't connect to yourself. So because there are 1, 2, 3, 6 on this, every computer has to have 5 connections. That means 5 places to plug in a connection, so 5 network cards, 5 sets of cords, and they all have to be direct. So you can imagine this is going to cost mucho money, but it is highly redundant, meaning it is very hard to take down this network. Because even if this connection gets shot, this guy can still connect by doing this. And if that connection gets shot, they can connect this way. So you can see there are so many connections that would have to go down. That's why this is still used. However, it is rare because the cost of implementation is so expensive that you're only going to see it in certain circumstances where the network going down would literally mean millions of dollars or billions of dollars going down, and a loss of time as well. So special environments that need that much redundancy would have it. Banks, government institutions, I'm sure, the military, etc. Finally, we have a hybrid technology. This combines 2 or more technologies. So for instance, we have a bus connected with a star here. Probably not going to see that as much as a star ring, meaning that I would have a star here, and then maybe I have another star, and then let's say here's my star, and then I have another star, and then these are all connected in a ring format. Okay, so that would be also a hybrid connection or a hybrid topology. So here's a star bus, or what's also called a hierarchical star, in which case, I have this computer, which is a star, and then it goes down to, so it's doing something like this, and then this goes down to another one, and this goes down to another one, and this is what we call a hierarchical star, okay? But this is a hybrid topology, meaning that it's mixing several of the topologies we've already seen. Okay, so now we've discussed topologies, including a star, bus, ring, mesh, and hybrid. So let's quickly just go back over everything we talked about. One, we talked about a networking overview. Again, networking means I have 2 or more nodes or computers that are connecting together, generally to share resources in some way, shape, or form. The networking types we looked at, local area network is a smaller geographic area. It could be covered by, say, your room, or a floor on the office, or an entire office building. Okay. Many LANs make up a WAN, which the biggest WAN in the world is the internet, a wide area network. The metropolitan or municipal area network is generally bounded by city limits or some such distinction. A personal area network dealing with Bluetooth. We then looked at the network topologies, including a star, which looks like this. You have a central device, and it is also the most common. A bus, which means that all connect through one backbone. A ring, in which the devices are connected in sequence. Mesh, in which every device connects to every other device. Okay, so this is redundant, but also very expensive. And finally, a hybrid, which is a mix of any other topology. All right, we've discussed networking types and network topologies, so now let's keep bulldozing into networking and talk more, and still in a general sense, about networking technologies, about the way that we set them up, and about the way we communicate over networks.